Oh, okay, so welcome everybody, and I'm gonna start. I'm gonna talk a little bit about a software that we started using here on campus about 2 or 3 years ago, for the very obvious reason that we're gonna see in a minute, right? It is available at no cost to everybody, okay? Whoever you may be, you can just download it and use it freely. Okay. Or you can use it in the cloud, right? So you don't even have to download it. However, there are some restrictions if you want to use it in the cloud. Okay. The full Jamovi program is not quite available in the cloud, so there are some restrictions there. It is easy to download. We're going to see that in a minute. It's already downloaded here, but anyway, and it's easy to access it. It's a great learning tool. Has really good graphics, which is important. Okay. You can copy and paste and get all your outputs to look very professional. It's easy to enter data. If you have a small data set, you can do everything by hand. Preferably, that's not how you're going to do this, but anyway, we usually import stuff from Excel or some other data source. And it's used around the world in courses, in universities, and in research. This was developed as to address the commercial statistical software, like such as SPSS, SAS, and Stata, which are excellent. They're really excellent. However, they're not cheap. Okay. Even the annual licenses are pretty expensive, depending on who you are. The academic license is like, I think, $800 or thereabouts. So just for 1 year. But anyway, SAS University is free, but it is challenging to run that. I like that software quite a bit, but it's not easy. It has a pretty steep learning curve. Okay. Same thing with R. Oops. The R here is also free, but you have to be good with programming and coding, right? But anyway, there's another really good software that's JASP here. It's very similar to Jamovi. Okay, it has some advantages and disadvantages when compared to Jamovi. But the problem with JASP here is you cannot enter data on your own. You always have to import data from another source. Okay. But there are some other things. In fact, the results in JASP are displayed a little bit more professionally, I think, especially if you have to write your paper in APA style. Usually JASP is the way to go. And it's very similar to Jamovi, right? Free, it's completely free, easy to download, and everything else. Excel is good for data management, and then they do have some, there are some really good add-ins that are really expensive if you want to do statistics in Excel. But I would just emphasize here, do not use Excel for data analysis. Okay. Their algorithms are not stable, so you may not always get the correct answer. Okay, Microsoft has known about this problem for 30 years and they haven't fixed it yet. Okay. You may be lucky that you may actually get the right answer, okay. But if you want to do things in Excel, okay, it's possible, but I would not recommend. Especially if you need to publish something or if you need to write a paper using statistics. Use Excel as a data management. That's where you can store data, that's fine. But to do actual analysis, I would not use it personally, but that's just me. Okay. It is my personal favorite, and when it comes to free software, Jamovi, because I teach statistics. So for me, I'm looking more from a learning aspect of the software. So it's just easier. It's very easy to edit data, add new variables, manipulate variables. We're going to see a little bit of that, how to filter data and stuff like that. It's very easy. And what's really nice about Jamovi, you have a lot of resources online. So whenever I don't know how to do something, I Google it, right? And I always find an answer, right? That's pretty good. If I'm not happy with what I see, I keep searching, and eventually I'm going to find either a video on YouTube or a web page that tells me exactly what to do. And that's nice. If you're more like a visual person, okay, that's fine. You have plenty of videos on jamovi, so we're going to get there in a minute. Okay, so let's get to the good things. So let's click on this thing. Hopefully this will work. Okay, so this is their download page on jamovi. It's just jamovi.org, and then you can go into download. I will always recommend to install the latest version, okay, or the current, as they call it, because the older version may still have some bugs that were unresolved. Okay, you never know. But and then of course pay attention to your operating system as well. Okay, so you're gonna select the one that you need. Okay, if you have a Mac, then choose a Mac. Right, the Chrome. That usually works, but not on Chromebooks. Okay, I had few students who tried to download this on their Chromebooks, and it just wasn't going to happen. Okay, either not enough memory, or it's just not. Something is not quite working well with the Chromebooks. Okay. So you would need something a little better, okay, like a PC, a Mac, or usual thing. Smartphones also don't. It's not gonna work. Okay. Not yet. Maybe in 10 years, maybe it will. We'll see. That's why it's good to stay current on the latest versions of the software, because you never know. New things do come up or are developed, you know. So the good thing about jamovi is they do update this several times a year. So I usually install the current version at least 2 or 3 times a year. I delete the old one, uninstall the old one and put the new one in, so that I'm on top of things. But they do update this like several times a year. So that's a good thing, right? That means that the researchers who are developing this, they really care, and they're catching all the possible errors that they may be there, you know. Okay. All right, so you would just click on your current version if you're using Windows, whatever. You just follow the instructions. It's pretty easy. Okay, pretty easy to do that. Also on this website, you have let's see, some resources here. Let's click on the user guide. Okay, if you like, you can. There are a lot of different topics here that you can look at. Let's see, where are we? jamovi. Okay, I'm gonna get to that a little later. Community resources. Yeah. So, so here you have a lot of different resources from different people who developed like a little guides of how to use the software. Okay. We have this very first on learning statistics with jamovi. We have it here in the lab. It's been printed. It's right here. So it's pretty good, but it's written by psychologists. So their examples are, you know what to expect. Yeah. But it's pretty well written, and so on. You have other things here in different languages, right, if you need that. But anyway, that's the resource page, and it has a lot of different things. Okay, let's see, features. Okay, we'll talk a little bit about that. So basically, yeah, this is what you would do if you want to install on your desktop, and then you're ready to go. Okay, so I'm going to close this for now. We are here. Let's see, what else do we have in the PowerPoint discussion? Okay, we can. Oh yeah, okay. So we talked about the download. Let's go into the videos here. Okay. All right. So here you have a lot of different topics. Okay, let's. Okay, fine. Okay, skip. And this is JASP for some reason. I needed jamovi, so okay, so I probably clicked on the wrong link, but anyway, there we go. Okay, I'm gonna just stop this for a minute. But yeah, I mean, you can scroll here and then get all different topics, right, depending on what you need. There are plenty of videos there. Chances are you're gonna find the video that you need and just look at visually how things are done. Most people like that, so it's easy to learn. Okay, and it's very intuitive, really. I'm going to show you that in a few minutes, right? How that works. But you can go, you can just type in the search jamovi. You're going to get a whole bunch of videos, and whatever you need to do, you know, sharing files if you ever need to do that, whatever, importing data, computing means, okay, transforming data, filtering cases. We're going to talk a little bit about that. How do I get histograms? You know, you would just watch that and see how that's done. Now, any questions so far? So there are plenty of resources, right? Plenty of resources, mostly online, yeah. So there are a couple of textbooks already that are printed, right, that use jamovi and JASP in the same at the same time. So, okay, so that I leave to you to explore if you need. So we are, let's see, what else do we have here? All right, so we can now go to, we're gonna go to here. Jamovi has already been installed here, so. So this is the version that's been installed on this computer. And this is where you would enter your data, and the results will be on this side. So it's pretty easy to use. So I'm gonna let's see, where is my here? I already have a data set here, so I'm gonna just click on it because the data set is already in the jamovi format. It just will populate everything with it that I know. All I have to is click on it and everything will be entered for me, right? But before this happens, you have to have your jamovi installed, okay? Otherwise, your computer is not going to recognize your data file in the jamovi format. Okay. Does that make sense? It's going to say, well, I can't do anything with this because I don't recognize this, you know, it's, I know. So you have to install jamovi first, and then everything will be pretty straightforward. Okay. So first, let's just see what we have here. It's very important to pay attention to the very first row because you have your variable names, and you have little symbols, right, in front of each, right? So what is this little symbol here next to student? What do you think? This is telling you what kind of variable student is in this data set. What kind of variable is that? Categorical, right? It's not numerical, right? That's what these little Venn diagram thing, I think it looks like a Venn diagram, perhaps, who knows, I don't know. But okay. A nice thing about this, you can code this very easily if you don't like string type of values for your categorical variables. Sleep, the number of hours students get. This is, by the way, a student questionnaire. So we're talking about student, university student population here, right? But this is just a sample, okay? Sleep, well, it has a little rule. What does that mean? Well, that means it's a quantitative or numerical variable, okay? Are we okay so far? Yeah. Then we can see what else do we have here. We have courses, all right, how many courses people take. If you don't like, for example, if you don't like these, whoops, I don't know what I did here. If you don't like the decimals here, let's see, for the courses, all right. You can easily change that a little bit here, right? You can just say integer, okay, under that variable, right? And then what will happen? Well, those decimals are gone, okay, because I'm specifying all I want is integers. Or you can keep it as an integer either way. Usually in analysis, it doesn't matter. Okay, so that's what you would do, okay. If you need to change, especially, this is important when you import stuff from Excel, sometimes you have to, sometimes jamovi is not going to recognize the type of variables correctly, so you have to change the nature, or you have to classify those variables correctly by simply clicking on here. Because if your variables are not classified correctly, you may not be able to perform some of the data analysis, okay. If you have a numerical variable, it has to be classified in jamovi as a numerical variable. Okay. You cannot keep that as a categorical. All right. So let's do some basic stuff. Let's take a look at studying, right? How many hours do students spend studying for their courses? All right, that's kind of interesting, right? Maybe. So we're going to start with very simple stuff here. Let's do some descriptives here, exploration descriptives. So this is pretty straightforward to use, right? What would you do? I'm interested in studying, right? So I'm going to select that variable, okay, and put it into the variables box, right? It's sitting there empty, right? So, all right. Let's do it this way. So here we are, right? This data set has 679 participants, okay, and so we have that's the sample size. We have 4 missing values, right? So really these calculations are based on 675 valid cases. Okay, those are the valid cases. Okay, and we see, right? Oh, okay. So on average, right, students at this university spend 8.6 hours a week studying. Not quite enough, is it? I was an outlier in this case. Anyway. Standard deviation is huge, right? What does that tell you? Well, that tells you there's a lot of variability here, right? There's a lot of variability here. Minimum is 0, so we have somebody who doesn't study at all, right? That's what that 0 means, right? And somebody who's studying 65 hours a week, right? Well, now that's, is it too much? Yeah, I don't know. Now, what if we need more stuff? Perhaps this is not good enough. Man, time flies, okay, when you're having fun. Okay, so that's okay. So we're going to go back here. And we're going to select a few more statistics, right? Let's get the percentiles, mode. Okay, this is really what you're doing here, right? However, you need to understand and know what you're doing so that you get the right stuff out of here. You need the range and the interquartile range. That's fine. We can do that. Oops. Okay. Outliers. Okay, maybe not. Okay. So now we can look at this table, right? We have our quartiles here, right? We have min and max range, interquartile range, right? That's the length of the middle 50, right? Middle 50%, right? The range of the middle 50. You have standard deviation, what you're targeting, and then the quartiles. Okay, let's get some graphics here. All right, so let's get back here. Just open the plots here, and let's do histogram and a box plot. Okay. Okay, I'm going to minimize this a little bit. So we have a nice visual representation, right, of studying hours per week. Okay. So yeah, there are obviously some outliers, right, on the right side, right? So what kind of distribution is that? It's skewed to what side? To the what?
Left, right? Oh.
Well, yeah, it's either one or the other.
Sorry, my brain was
Yeah,
crazy.
it's okay, right? This is skewed to the right. 'Cause you have a lot of unusual observations on the right. Okay. Or positively skewed. And here's your box plot, right? The nice thing about it, right? It will label the cases that are really, really highly unusual, right, when compared to the rest of the data. Okay. So now let's get back to descriptives here. What if can I add another variable here? Yeah, sure. We can add sleep as well. Okay. So you can build your table as much as you want, right? Sleep, yeah, the average number of hours that students get sleeping, right? That's also a numerical variable, so I can talk about mean, median, mode, standard deviation, and also all those other things. So I can keep adding these numerical variables in the table, right, if I need to. It's kind of nice, right? Mm-hmm.
The studying column is only how much they studied, but not in comparison to how many courses they took.
No, yeah, right.
So
you can compare.
could you extrapolate out studying per course? Because you can study all you want, but if you're taking one course, that's pretty bad.
Right. But you can correlate those two variables and see how that works. Yeah. Or you can split that up, right? Depending on, this is not a categorical variable, but I can extrapolate that using regression and stuff like that. Okay. Now we can split this up even more. Let's get back to descriptives here. Let's split this up by by employed. Okay. So let's see what happens here. Okay, so now I can look at stratified results. Okay, I know that I had 300 when I look at the studying, right? 300 valid entries, right, for the part-time students who work part-time, right? Full-time we have 124 and not employed 245. Okay, and then I can look at there are mean, okay, and everything else. Let's see. And yeah, here we go. So studying, okay, so we can look at the means, right, of the hours that people spend studying, right? Part-time students on average study 8.44 hours, full-time 8.6, right? And not employed 8.8, stuff like that, right? So I can stratify that with respect to, so I have to have a categorical variable now that will make these different levels, right? If I want to compare. Does that make sense? So I can see exactly what each group does, okay? And let's see, did our histograms change? Yeah, they did, right? So your outputs will automatically change as you change what you request in the statistics section there, right? So we have histograms for each level. It is part-time, full-time, and non-employed. I can compare the distribution of studying hours, right? And then of course we also have their box plots here, and stuff like that. How are we doing so far? Okay, so we are almost out, so we need to go quickly over here. I want to talk a little bit about, what did I say? I want a student. Okay, I'm going to put that in rows, and I want to do employed. Okay. Okay. So we can very easily create cross tabulations by using categorical variables now. Okay, categorical variables, and these are very good when you start talking about probability. Okay, and this is what I use quite a bit. This is telling you exactly. I have 97 full-time students who are also attending college full-time. Right? So I can summarize my results really quickly. Okay. If you know the chi-square test, right, you would look at the results here, right? Okay. If you know how to do that, that's fine. I'm not going to go into that right now, but anyway. But I want to show something else here. In the cells, I want to look at percentages and just quickly talk about that because this is where most students have issues when they hit probability in statistics. Yeah, this is, this becomes kind of an issue here. But anyway, okay. So first question, for example, what percentage of students who are employed part-time are actually part-time students? How would I find that number? So what percentage, right? What percentage of the students who are employed part-time, so I'm going to look at this first column, right, are actually attending university part-time? That's the so-called conditional probability, right? If you ever heard that name, that's what you're talking about, okay? So how would I figure that out? Using these percentages, right? This is already calculated for me, right? In fact, okay. Now we are conditioning by the part-time, right? Employed part-time, right? So the total is 301, and we have 6, right? That are in the category part-time and part-time, okay. So it'll be 6 out of 301, and that's almost 2%, right? 1.99%. Okay, that's an example of conditional probability, right? So I can now say that 1.99% of all those students who are employed part-time are actually part-time students. Does that make sense? Their enrollment status is part-time. They're not full-time students, they're part-time students, right? So I could find that number right here, right, within column, right, because we are conditioning by variable category that I put in a column. Okay. You could have reversed that, right? You could have put employed as a row and the other variable as a column. It doesn't really matter. Okay, as long as you know what you're doing, you're always going to get the same answer. Okay. Okay, can you tell me what percentage of full-time students are not employed? Where would I find that answer? So what percentage of full-time students are not employed? Is it that one? What percentage of full-time? Now we are conditioning by the category that's in the very first row, right? So I'm going to be looking at within row, right? So that's what, 37.97, right? Because we have what? We have 240, right? Divided by full time, right? 632. I have 632, right? Full time. Does that make sense? So yeah, you can use either percentages within row or within column, right? Depending on what you are interested in. Okay, what you're interested in. Okay, really quick. Suppose I want to filter this a little bit because I'm running out of time, unfortunately. But let's click on data and let's click filter here. Suppose we want to do analysis only on students who are full-time students and and are not employed. Can we select those cases really quickly by filtering? Yes, yes, we can, right? So what we could type this as student, right, equals, because this is a categorical variable, I have to put the name of the category in quotes. I want only full-time. And what else? What else did we say? Category. We said employed. Okay. And that's the variable name, employed. I want to select only. What did I say? Not employed. Oh. Okay. All right. And there we go. So now the filter is on, right? So now the filter. So what happened? Because I'm only interested in this group of students, right? I want them to be full-time and I want them to be not employed whatsoever. So this way I selected, right? You can see, right? You have a little check mark on those cases that are selected. So now you can work with this subsample, right? Or a subgroup of the original data set and study that particular group if that's what you're interested in. Okay, and you can keep adding filters, or you can just, if you're done with this, okay, yeah, I don't need that filter anymore, I'm done. All right, if I'm interested only in students who sleep at least 6 hours, okay, that's the only group I'm interested. I don't care about those who get less than 6 hours of sleep. For whatever reason, I can do that too, right? Okay. So if you can see here, right? Yeah, this student was selected because that person was getting 6 hours of sleep, right? And that's how that works. Right? And there are a lot of different things that you can talk about here. I had something for you to do, but since we are unfortunately running out of time. Okay. There is so much more. There is so much more here, right? I don't know everything about it, but you know, it's very easy to use. That's the good thing, and very easy to import data if you have it in Excel, especially Excel.
Is it easy to export it? So if I wanted to
Yes. Yeah, you can. Yeah, you can export everything. So. If you want in PDF, you can export in PDF. You can do it in Excel. You can do whatever you want. Your results, if you want to save them. Mm-hmm. And then you can edit that in Word, right? If you're writing your paper in Word, you can arrange your tables and graphs very easily. So. All right.